So in this video we're going to look at what happens when we differentiate functions with the natural log of x, and you'll remember from the proof video that if we differentiate log of x we get 1 over x, and if we differentiate the natural log of f of x we get f dash of x over f of x. So let's look at some examples of differentiating functions with a natural log of x where we've got a product and a quotient. So in our first example here we're going to look at a product. So if you remember, when we're differentiating a product we differentiate one of the factors and keep the other the same, and then we do it the other way round. So if we differentiate that bracket, we multiply by -1 and then take 1 off the power to give us minus 5x to the minus 2, and then we differentiate the 2x squared to get 4x, and then we keep the other factor, the log of x, the same. Now what we're going to do is to differentiate the log of x and keep the bracket the same, and we'll remember that when we differentiate log of x we get 1 over x, so it's just going to be plus our bracket divided by x, because multiplying by 1 over x is the same as dividing by x. Okay, let's have a look at another example now, a quotient. Now it is quite useful when we're differentiating quotients to actually separately differentiate the top and the bottom, because we know we're going to use those values. So when I differentiate 3x plus 1 I get 3, and when I differentiate the natural log of x I get 1 over x. So we'll remember that you get the differential of the numerator multiplied by the denominator, 3 log x, and then it's minus the numerator multiplied by the differential of the denominator, and the differential of log x is 1 over x, so that gives us 3x plus 1 all times 1 over x, all over the denominator squared, so that's the natural log of x all squared. Now that looks always a bit messy. I don't like having fractions within fractions, so if we multiply every term by x, the 3 log x becomes 3x log x, the 3x plus 1 times 1 over x, well the 1 over x goes, and the log x squared times x just gives us x log x, which gives us this term here, which although it's still complicated is simpler than the one that we've got above. So now let's do an example which involves the chain rule. Now we don't directly differentiate square roots, we first of all change those to a bracket to the power of a half. So what we need to do is multiply. If we had x to the power of a half, we'd have a half x to the minus a half. So we're going to multiply by a half, keep the inside of the bracket the same, and then take 1 off the power to give us this. But it's the chain rule, and if you remember we've got to multiply the result by the inner part differentiated. Now when we differentiate the log of x squared plus 5, you'll remember from our proof video that that just becomes the differential of x squared plus 5 over x squared plus 5. So we're just going to multiply by 2x over x squared plus 5, and we can see that this simplifies, the 2's cancel, and then I'd like to bring that multiplication to the front to give us x over x squared plus 5 times the natural log of x squared plus 5 to the power of a minus a half.